Good morning. Good morning, everybody.
Good morning.
Oh. Hi, Georgina. All right, we're going to get started this morning. Hope you guys had a great weekend. I don't know if you heard, but I had some major internet problems last week, and those issues are not resolved. I tried to take care of things on Thursday. My internet provider was supposed to send out a new modem. They supposed to deliver it, but said I wasn't home. So I'm still having problems. So the system may crash this morning during the middle of my lesson. I am going to try to record it, but if there's any problems, I will send out a message, and we might have to get into the Math Wizard teams. But I'm going to try my best. So far, so good. Can you all hear me? Okay. All right. Thank you so much. You guys are so cute. Thank you. All right. So tonight, lesson P5 is due. That is the factoring. And so I want to make sure that I take any questions that you might have about the factoring. And then on Tuesday morning at 8 o'clock, I want to take that P5 exam. So I want to just try to get any issues resolved about the factoring. I have spent more time than normal with the factoring because of the importance of it. Next section, we're going to be simplifying rational expressions. I'm using factoring, and you already had a taste of that last week. So anyhow, I want to take any questions you have about the factoring packet, the puzzles. I also assigned more complicated problems in the book that required more than one factoring method. So for example, you might have to factor using a GCF and then turn around and do the difference of squares. So you have to factor completely. So sometimes students think that they're gonna factor once and that's gonna be sufficient, but you always have to look at your end result. And if you see higher powers, you have to see if you can factor even further. All right, so I hope you're doing well. I'm really happy that you're able to see and hear me. Yeah, there were video and audio problems last week. So do you guys want to ask me questions about the factoring?
Ms. Birch.
Yes.
Can we go over some problems in the book or no?
Absolutely.
I was gonna ask you, I had a little bit of trouble with the factor of each perfect square trinomial.
Okay.
Yeah.
All right. Do you have a particular problem you want to look at?
I would say like 51 and 55. That was just like, it just threw me off. You know what I mean?
Okay. No problem. Let's take a look at it. Is this the one you're talking about? X squared minus 4x plus 1? Plus 49?
The x squared minus 14x plus 49.
14.
Yeah.
Okay. All right, check this out. After you do a GCF, which we can't do in this, you always want to do a GCF first. So if you do not do a GCF first, it may not be factored completely. So we have to build one cake and do a GCF, and we can't. So hold on one second. I have something coming across my screen. Okay. We can't do a GCF. So what we do is we go through this list of factoring methods in this order. So it's not grouping. We don't have 4 terms. We don't have 2 terms. So it could be a perfect square trinomial. So what you want to look at is this. Is this a perfect square? And is that a perfect square? And this has to be addition, by the way. If this is a minus, it cannot be a perfect square trinomial. So
because it's a negative then, right?
Well, okay, watch this. If you try to make a square, right, there's no way that anything times anything is going to give a negative.
That's true. Yeah, yeah.
So that last term, that third term, cannot be negative. So if you remember when I taught this, I did a 3-step test. Do you remember that, Bernie?
Yeah, I remember that.
Okay, check this out. Watch. Is the first one a square? 1 times 1. Is the third one a square? Yes, it is. I'm sorry, 1 times 1 and then x times x. 1x times 1x, right? And then you take this x and 7 and you get 14x. Now, if it matches it perfectly, it's the square of a sum. Excuse me. If it differs by a negative, see how it's exactly the same as the middle term, it only differs by a negative? It would be a minus. And all you do is put x minus 7 and you're done. Now,
That was way simpler than I thought it was going to be.
Yeah. And if you work a whole bunch of them, you get good at it.
Yeah,
So
yeah.
whenever you have 3 terms, if these are perfect squares, you do this 3-step test and see if the middle term, if they match exactly, that's going to be the square of a sum plus. If they differ by a negative, it's going to be the square of a difference.
So, Miss Birch, okay, so let's just say there was a, okay, for 53, it's 4x squared plus 4x. Like, what happens with the 4x squared? Like, the first number. You know what I mean?
It's the same exact, let me erase it.
Okay.
I wasn't sure if I'd be able to teach you guys this morning because it was horrible last week. Nobody could see me, nobody could hear me. It was the picture was pixelated. So let's take a look at 53. Okay, so once again, you look at your list and you can't do a GCF. It's not 4 terms, 2 terms. It looks like it might be a perfect square trinomial because 4 is a perfect square, 2 times 2, right? Or I'm sorry, 2x times 2x, and 1 is a perfect square, 1 times 1. So we're going to do the test. Is the first one a square? Is the third one a square? So the first one's a square, 2x times 2x. Did you follow that or no?
Yeah, I get that.
Okay, and then 1 times 1, and then you put your 2x near 1 is 4x, and look at it, matches it perfectly. It matches it perfectly. So it's the square of a sum, and all you do is put the x and the 1 in there. Oh, wrong color, I'm sorry. So Bernie, all you do is make squares. And if you can create a square, then it's a perfect square. If you can't create the square, then it's not.
Okay. That makes sense.
Yeah, and it's easy,
then,
right?
Yeah.
Because
Okay,
remember,
so like,
yeah,
go on.
remember that a square has 4 equal sides, right?
Yeah.
So if you can draw squares for the first and the third, then it could possibly be a perfect square trinomial, but you always have to check the middle term to see if the middle term, because it could fail.
Yeah.
If it fails at any point, then it's not a perfect square trinomial.
And then what do we do from there?
You would have to try another factory method. You
Okay.
have to try factory method 5 or 6.
All right.
Because remember what I said, on this list, number 3, 4, and 5 are special cases.
Yeah.
So we're hoping that it's 3, 4, or 5 because the special cases are easy. Okay, that help?
Yeah, that helped me.
Okay. That's good. All right, anybody else?
I had a question on
Georgina, you're breaking up, and I don't know if it's me or you. Can you repeat that?
Okay, for number 35 on the textbook.
Yeah. And you guys are going to practice for the exam on the globes in your online textbook, right? So you know how to input. Remember the problems that I had last time trying to grade it? So you guys have to know how to input the answers. All right, so this is 35. I'm not going to give you this hard. What is it, plus 3xy? Plus y squared, yeah. Yeah, I'm not going to give you anything this hard. This is actually, yeah, this is kind of a special case. Now, okay, first of all, Georgina, see how you have two different variables? So this is kind of an advanced problem. So rather than trying to teach you something with this, it's better, it's probably just a guess, you know, so let's just guess. A 2 has to go somewhere, and we normally see the FOIL method like this, right? So I'm just going to mess with this like a puzzle and just see if I can figure it out, because this problem is, you don't see very many of them, and it's not worth spending a lot of time on it. All right, so over here, we need a y and a y, right? So let's just FOIL it and see if it works. I just guessed. All right, so first, outer, inner, last on the FOIL would be 2x squared. Outer would be 2xy plus xy. I'm putting them in alphabetical order, so I notice the like terms, and look at this. That's a 1. So there really is no factoring method for this. I just kind of just looked at this and said, okay, I need 2 numbers to multiply to give 2x squared, and I need 2 numbers, I'm looking at these, I need 2 terms to multiply to give y squared. And I just guessed and I got it. Are you okay with that explanation, or is that bothering you?
I don't know.
Okay. Okay. I'm not going to give you anything like that.
Miss Birch,
Yes.
what problems are we gonna see, or are we gonna see like every problem for factor using the formula for the sum?
Okay, listen. Okay, so one thing about teachers testing is you kind of want to figure out how teachers, whether it be history, English, everybody kind of has a style. So if you notice with me, I'm giving you problems like in the first 4 to 6 problems. So in each section, if you know how to do the first 4 or 6 problems, you should be good to go. I'm never going to give you problems at the end of each set, because did you notice that those are more complicated?
Yeah.
So I'm not trying to pull a fast one on you guys. I just want to know, can you do the most basic problems? And so it's going to be the first 4, maybe 6, the first 4 to 6 problems in each set.
Okay.
Did that answer your question, or is that what you were asking me?
Yeah, that's how I was asking.
Yeah.
Miss Birch, can you do number 47 in the book?
Sure. Can you guys see everything okay? And are you hearing me okay?
Yeah, just Miguel
Okay,
was
good.
telling me that he had to leave the chat room to come back because I guess he couldn't hear you. His computer was messing up.
Okay, well, hey, as long as it's not mine. I had major problems last week, so my students it was horrible. So as long as it's not me, there's only one worse than the students going out, and that's the teacher. 47, is it mine? Okay. All right, so remember, you want to do a GCF first. So you want to look at this and see if you can do a GCF. So what you do is you think of the factors of 16. So the factors of 16 are 4, 2, 4, 16. Well, 2 and 4 are not factors of 81. So there is no GCF. So look at this thing. Isn't that 2 terms? So couldn't it be the difference of squares? So watch what I'm going to do. I'm going to see if it's the difference of 2 squares. And if it is, it's the product of a sum and a difference. Right? So this would be 4x squared, right? 4x squared times 4x squared. And this would be 9 times 9. So it would be 4x squared plus 9 times 4x squared minus 9. And it looks like we're done, but we're not. Okay, look at this. You cannot factor the sum of squares. You can factor the sum of cubes, but you can't factor the sum of squares. But look at this. Isn't this the difference of squares again? So watch. This guy floats down. And this one, we're going to see if this is the difference of squares again. Oh, darn. And if it works, it's going to be the product of a sum and a difference. So wouldn't this be 2x times 2x? Bernie, are you following this?
Yeah, I am. I'm looking at it right now.
Okay. And then 3 times 3. So this would be 2x plus 3 times 2x minus 3. And so what we had to do the difference of squares twice. And how did I know this? Look at this. See how big that power is? That means more factoring. So if this had been a quadratic, we would have probably only had to factor 1 down. Remember what we're trying to do here? We're trying to break down the power so we can solve it eventually. So the reason why we're doing this now is we're trying to break down the power so we can find out where the graph is crossing the x-axis. That's what we're trying to do. So when you see a big power like that, you should expect to factor more than once.
So, Ms. Birch, because to me personally, I thought that this one was kind of like more simpler, you know, like 39 through 47, because all you're doing is just factoring. You know what I mean? Yeah. Like into like the most like simplest form then, right?
Right.
Yeah. That's why, you know, like for 81, what goes into 81? 9 times 9, then what goes into 9 times 3. You know what I mean? And then nothing else goes into 3, so that'll be your answer.
Right.
Yeah.
Good. Good job. But you're not, you guys aren't going to try to, I might try to trick you on one little problem. So if I give you something like this, x squared plus 4, you're not going to try to factor that, right? That cannot be factored. X squared plus 9, that cannot be factored. There is no factoring method for the sum of squares, only the difference of squares. You have the sum of cubes though, but you don't have the sum of squares. These are simplified. You cannot factor those.
Why are they simplified though? Just because like they're squares?
You can't factor them. So these are simplified because you can't factor them. There's nothing that multiplies to give x squared plus 4. Nothing. See, these right here are the factors. These are the binomial factors that multiply to give this polynomial expression. Well, there are no factors that multiply to give these guys. These are already simplified. There's nothing.
Yeah, I mean, it's also like Like the hint for that also is the addition sign, or does that not really matter? Because
Yeah,
for 30,
yes.
okay.
The addition sign, you can't factor the sum. When I say sum, S-U-M, sum means add. Difference means subtract. So when I say the sum of squares, I'm saying, yeah, you can't factor when you have adding squares.
Yeah. Okay.
But don't get confused. You do have the sum of cubes though.
Okay. But you can do cubes, but just not squares.
Right. Exactly. That's exactly right. All right, you guys are doing an awesome job talking with me. Anything else?
Can we do some problems for the 65 through I believe you said to do it up to 81. Like could we do like 2 problems from there? That section?
I gave some problems. I gave 2 or 3 problems from that section. And that section includes more than one factoring method. So yeah, we should. So what do you want to do? Don't do the hardest, like 91. I didn't put any of those in, but you should know like 65 through like 77. You should know how to do those.
Could we do 67 and 71?
Okay, hold on. Let's do 67 first. You guys can still hear me okay?
Yeah.
Okay, good. I prayed about this, so God is helping me today. I appreciate it.
I think I'm the only one who has a problem with it.
What's that?
I think I'm the only one that's had a problem with it because, like, sometimes the audio will cut off and then I have to exit and rejoin and then it'll cut off again and I have to exit and rejoin.
Well, I have a new modem coming today if it's on my end, and I have a tech guy come into the house to fix all of my problems, hopefully. So on my end, it's going to be resolved. Okay, so on this problem, you can do a GCF, right? And you're supposed to do a GCF first, right? Don't forget. So 4 times what is that? X squared. 4 times what is that? Negative X. And 4 times what is that? Negative X. And what you have now, this is not a perfect square trinomial. This is factoring method 5. Now remember, factoring method 5 is a special case. All you have to do is find out what multiplies to give a negative 6. Remember, negative 6 times 1. And what adds to give a negative 1. And you write your answer. That's why it's a special case. So you have 2 times 3, where 3 is negative. And that's the answer. X plus 2 times X minus 3. And you're done. So you had to do a GCF. And you had to do factoring method 5. Right?
Right.
Okay. You want to try another one?
Yeah.
Yeah, I would make sure you know how to do this one. This looks like something I would put on the exam.
Are we going to have a problem? Number 81?
You're breaking up. Say it again.
Are we going to have a problem like number 81?
81?
Mm-hmm.
No. You are not.
Can we do like will we get a problem such as 75 or 77?
75, yes, maybe. 77, yes.
Could we do either of those? Or both of them if you want? Or yeah.
Okay, let's do 75. This time I'm going to ask you what to do, so unmute yourself and tell me. This is x cubed minus 4x. So somebody unmute yourself and tell me, what should we do?
GCF.
Are we going to use UCF?
That's right. So we're going to take out an x. And x times what is that? X squared. X times what is that? Negative 4. And doesn't that look like the difference of squares? Yes?
C.
What's that?
Yes.
So x plus 2 times x minus 2, and the x floated down. So let me just tell you something where we're going with this. This cubic looks like a snake. Later, when I ask you to solve this, you're going to say, what makes that 0, 0? What makes that 0, negative 2? And what makes that 0, positive 2? And so what's happening here is this graph is crossing at these points, and this graph looks like this. So that's where we're going. We're using factoring to break down the snake. The snake is crossing the x-axis at 0, 0, left 2, 0, right 2, 0, and it means that it's doing this. So we kind of know what the graph looks like. We're not doing that right now, though. We're just factoring. But that's where this is headed. So you're going to have to solve polynomial equations, major concept in algebra. And so we're going to be using factoring when we can. It doesn't always work, though. So there's other methods for solving polynomial equations, but factoring is going to be one of the methods. Now, I just talked about this. So let's see what you guys say. Can you factor this?
No, because it's a.
No, because it's what?
It's the sum of.
Yeah. Good job. It's a sum, so it cannot be factored. Good job, Georgina. Remember, Bernie? Remember we were talking about this?
Yeah, because you can't factor a sum, so that's why you're just gonna leave it there. Yeah.
That's right. So that's the answer. Good job. Anything else?
Can you do problem number 25?
25. Okay. This doesn't look nice. And I'm hoping we can do a GCF, but we can't because the factors of 25 are 5 and 5 and nothing comes out. So guess what? This is the worst method. This is factory method 6. So I'm glad you asked about this because I think I did put a problem or two on this. So you got to multiply to get 28 times 3 is 20, is it negative 84?
Yeah, it's negative 84.
So we have to multiply to get a negative 84, and we have to add to get a negative 25. So this is a real pain in the rear. 1 times 84, 2 times 42, 3 times what is 8? 2 with the 2 left over, 26. That's not right.
8.
What is it?
It's 28.
28. Okay, look it. That might be it. Because we have to add to get a negative 25. So we have to multiply to get a negative 84, and we have to add to get a negative 25, but you can't write the answer. This isn't factoring method 5. So remember last time we wrote the answer, x plus 2 times x minus 6? Can't do that. So this is the one that's a lot of work. You got to bring down the 3x squared. You have to bring down the negative 28. You have to split up the middle term to the factors. So I'm going to put plus 3x there and minus 28x there. Now I'm going to do grouping 2 by 2. So the first GCF is 3x times what is that, x? 3x times what is that, 1. Over here, I want to take out a negative 28 so I can get my cakes to match. So negative 28 times a positive x gives me that. Negative 28 times a positive and my cakes match. So I'm done. So my answer is 3x minus 28 times x plus 1. Now, when you have to do this, see this number? If that was a 1, we didn't have to do any of this work. We could just write x plus 3 times x minus 28. But when there's a coefficient other than 1, you have to go through all this work. It's a pain. It's the worst one. This is factoring method 6. You guys okay?
Yeah, but like for 29, what I did the same thing. You know, when you have to put like the multiplication and addition. You know, you have to, like, you know what I mean, though, right, Miss Rich?
Yeah, 29. 29 looks like factor method 6.
Yeah. The answer I got was 2x plus 3 and then 2x plus 5. I wanted to know if that was right or not because I didn't look in the back.
Okay, watch. You know what I'm gonna do? I'm gonna take what you said and I'm gonna multiply it out and see if we get the original problem. So watch. Hold on a minute. Let me write this up here. All right. Tell me what you got again. What did you get?
For 29, I got 2x plus 3. And then for the other one, I got 2x plus 5.
And watch. I'm going to FOIL it. So that would be 4x squared. The outer would be 10x. The inner would be 6x. You're multiplying. Remember, you're multiplying. And then 15. So this turns out to be 4x squared plus 16x plus 15. And if that's the original problem, guess what? You did it right.
Wait, Ms. Birch, all you have to do to check your answer is just to FOIL it?
Yes.
For every one like that then, right?
When it's two binomials like that, you can't do that. With the GCF, you would have to do distributive property.
Yeah.
But when you have the product of two binomials, that's just a FOIL, right?
Okay.
So I wanted you to, I didn't even have to look at my book. All I had to do was FOIL it to see if you were right, and you are right. Good job. Okay, so since I've been having so many issues with my internet, I'm gonna, Miguel, can you mute yourself? Miguel? Are you there? Can you mute yourself? Thank you. Since I've been having so many problems with my internet, I'm gonna let you work in the Math Wizard teams, and we are getting a lot better. One of my classes wasn't doing so good, but I was so messed up with everything. I didn't get upset with them, but I need you guys to keep asking questions like, what problem are we doing? Okay, what do we do? What do we do next? What should we do? And you're talking out loud and trying to improve on that because you're gonna really love the outcome of it. But you have to trust me. You can't just go on your own way. You've got to trust me and try to practice this. And so we're going to go into those teams right now. We have until 10:45. And if you need me to work some more problems, I can come into the group. Just let me know. But we're going to study for the exam. So remember that like I said, P5 is due tonight. And the exam is Tuesday morning at 8 a.m. And listen carefully. Make sure you practice the online globes with your e-text so that you know how to input the answers. Remember I went over all the different answers people were inputting and the computer was marking them wrong. And I told you I'm not going to deal with that this time. You have to practice online to know how to input the answers. Okay? All right, I'm going to see you in your teams. I haven't changed them just because I haven't had time, but I will eventually change the teams up. But can you go into the teams? And if you need help, let me know. But here's what you're going to do. People are all different places. Some people are finished with the assignment. Some people have not even started it because I don't know why. Some people in the middle of it. I don't care. What you're going to do is grab some scratch paper, and just take turns. Maybe Brandon says, let's work 45. And then Bernie says, yeah, let's work 75. And Georgina's saying, let's work number 2. And you're just going to work together and try to work as many as possible. This is very powerful if you do what I say. Okay? All right, so I'll see you in those teams. We're not checking back. Class is over at 10:45, and I'll be checking in with the groups. Okay? All right, so I'll see you in the Math Wizard teams.